Appreciate everyone joining us on this Monday for this month's training on heat trace. We've done the products, we've done the overviews and all that in times past, and now we're going to do a little more detailed training. It's been a while since we've gone over our ChromaTrace software and some pipe layouts, and I'm sure enough of you have heard me talk enough, so we're going to have our in-house experts, Charlie Moden, and next week we're going to have Chad Gautreau do a presentation on our heat trace. But today specifically, Charlie's got some insight into using our heat trace pipe design guide, and then he's going to go through a deep dive in our ChromaTrace and show you how that can be useful to yourself and more importantly serve your customers. After which we're going to have invites. You've already seen the invites, so this will be we're going to create a customer version that will be done on this coming Thursday, and that will be for you to invite anybody, any of your customers, anybody you feel will get benefit from it. Speaking of benefit, Charlie's going to go through that now. So Charlie, I'm going to hand it off to you and show us what you got. Okay?
All right, you got it. Let's see if I can take it here. ChromaTrace. So we're just going to concentrate on lines, on pipes. So when you start it up, you're going to have a default line. You can select on that. You can put a new one, however you want to do it. But this is where all that information we just talked about, you're going to come in here and fill out. So for this one, we'll just call it a caustic line. We'll pretend we don't even know the line number. I'm not going to get into parent, child. I personally don't mess with it a lot. It works great if you're trying to design a very complex system that may have one main header and a bunch of branch lines coming off of it. You can actually do a parent and child line, and it'll calculate number of T's, things like that you need. When I have an application like that, I usually just kind of figure it old school by hand. So line name, maintain temperature on a caustic line. We'll run it at 90. It's a little hot, but minimum ambient, we'll call it 0. And you can see it automatically changes our startup to 0, which we want to leave it. That's where we want it to be. We'll bump our safety factor up to 20. Maximum ambient, you can leave this at 110 degrees. What this temperature does, this input, is it's gonna calculate your maximum sheath temperature or maximum operating temperature. So if your controls fail and your heat trace runs away, it'll calculate on whatever your maximum ambient temperature is. So that's what that number is for. Max exposure, we talked about that. If you look down at the bottom, it's constantly running. It's running live all the time. Right now we're having SRL cable. If we change this to, let's just say 300 degrees, it'll change this to SRME cable. So it's kind of foolproof, but put in what you know it is. We'll put in 170. That'll take us to SRP. If you take it down to 150, that'll take you back to an SRL. Max operating temperature, I don't worry about too much unless it's a hazardous area, and we can spend more time on that when we talk about optimizing design. And then your max allowable. Let's say we had a corn fructose syrup line like we were dealing with the other day, and that pipe could only get to a certain temperature. You can put that maximum allowable temperature in right here, and it will prevent you from designing a heating cable that will affect the product. So that's what the max allowable is. Voltage, we'll leave it at 120, but like I said, always ask what your available voltage is, plus what is your preferred voltage. Breaker size, we can go up to 50 amps now. This does nothing more than calculate your maximum circuit length when you enter that. Phase to neutral, phase to phase. I haven't seen a lot of difference in that, but if it's phase to neutral, it's a 3-phase 4-wire system. Phase to phase would be 120, 240. It doesn't make a lot of design when it doesn't make a lot of difference when you're just designing the heating cable. So don't worry too much about that. Cable types, we'll leave it like it is because this is actually giving us a design already. This would allow you, if you wanted to come in and force a cable just to see what your output would be, you can select the family. After you've selected your family, say we're at SRL 8 now, say we want to go to 10 watt, it's going to put it in there, but it's going to give us an error message and say we're exceeding our max maintained. So if you just wanted to play with it, you can by default stick a model in there. Where that is very handy is if you're dealing with MI cable. You can go in and play with different resistances and see how it affects your output. Attachment method. If we're designing a fiberglass pipe, you'll want to use the aluminum tape, metallic pipe, straight fiberglass tape, and then MI cable will use stainless steel tie wire. So you can select those options here, or we can just leave everything at auto. The number of circuits, that is exactly what it is. That's not the number of breakers, that's the number of heating circuits. The trace ratio per cable, that is the number of passes. And if I understand right, we're currently working on the next update for ChromaTrace, which is going to change the wording of this a little bit and make it, more user understandable when you're talking about trace ratio per cable, number of circuits. It's gonna make it a little bit easier. So that's your main screen. You can see we have a design here. You go to your pipe / installation tab. We'll leave it at, here's your steel pipe, but here's all your options. We'll leave it as steel, and we will also leave it at 2-inch, but here's all your pipe sizes. And we're going to call this, we'll just call it 100 feet. All right. So you notice down here in the bottom, we've got a total cable length of 100 feet. Excuse me. That's because we have not taken into consideration any heat sinks like we outlined on that pipe design worksheet. Those inline devices that require extra cable. You would input those over here. If you had one gate valve, stick it in there. You see we've increased our total cable length now by 2.5 feet. On pipe supports, you can either, if you know the amount of them, you can enter them. If you don't know, you can do foot spacing. So we're going to say that there is a pipe support every 20 feet. Let's see, we just keep adding our total cable length now. So that option is there. I never knew it was until the other day, which is pretty handy. So if somebody doesn't know, you can actually put it in there. Insulation. It is what it is, like I talked about before. Know your insulation. Fiberglass, mineral wool. These are just like they say, they're fibrous material that will compress around a heating cable when it's taped onto a pipe. Your calcium silicate, cellular glass, polyisocyanurate, urethanes, those are rigid insulations that must be oversized. If you've ever looked at this program and wondered what this use oversized means, that's what it means. That means it's going to take the nominal ID of the insulation and it's going to oversize it by 1/2 inch or 1 inch, depending on the size of the pipe, to allow room for the heating cable between the pipe and the insulation. With fiberglass and mineral wool, you don't need to use it because it will compress around the cable. So if you notice, if we go say calcium silicate, we would always click oversize, and it affects your heat loss. If you look down at the bottom, 9.6 watts per foot with it oversized, non-oversized is 8.4. So it is critical to know your insulation and your insulation thickness. So we'll plug in 1.5 inch. Additional cable, I always plug in an additional, I don't use percentage as much. I'll usually always plug in 6 to 10 feet of additional cable just for terminations. You're going to have 3 foot at least at a minimum on your power end and on your end termination to make up the box, make up the termination. So you're going to have some scrap. It will calculate into the design, but if you're bringing up a bill of materials, it's going to be accounted for. So that's, I always use at least 6%. So we've done all that, and we go to environment. This is where you can use the approval region. For the majority of us, it's going to be USA or Canada. If we do need to mess around with Europe, ATEX, we can select it here. And all that's going to do is help us select components, as well as it changes some of the design criteria, but not much. Classification, if you pick class 1, it's going to automatically default to division 2 group D. So if you don't know it, use it as a minimum if you know it's a division 2 area. Like I talked about in design on T ratings, we can enter a T rating. If you look at our cable data sheets, you'll see that certain outputs of cable are only rated for certain T ratings. So that's where these numbers come into play. We deal with these all day long when we're designing heaters. It's no different on heat trace when you're in a hazardous area. If you don't know the T rating, you can plug in the auto ignition temperature. So those 2 options are available. Sheath temperature calculation method, I never really mess with this for basic design. You can do a limited design, control limited. This says, you know, like that corn fructose syrup line we were talking about, if we can't exceed 150 degrees, we can go in here and plug that 150 in as just kind of a safety buffer to not let us burn the product. So that is there. Indoor, outdoor is what it is. Wind speed, like we talked about, standard defaults 20, unless you're dealing with excessive winds. And then here's your chemical exposure. If you'll notice, we have a CT cable selected right now. It defaulted to it. If we changed it to something mild, like just water, you know, standard freeze protection, it changes our jacket to CR, to our polyolefin jacket. So this being caustic, we'll say strong. It took it back to a CT jacket. Your miscellaneous information, change code, I just gotta be honest with you and tell you I'm not real sure what that is for. Drawing number is what it is, just like it was on that design worksheet. We want to plug that in if you want to. I'm going to show you an easier way to do it here in a second if you have a line list. The area, I use the area for if I know I'm going to have more than one panel, I will say area, I will call this panel 1. And I'll show you in the reports in a minute why I would do that. So for every circuit I design for panel 1, I put that as area. You can put any kind of comment you want, reference number, and then fluid, I never mess with it. This is really built to do heat up, which I think we originally thought we were going to work into our program. This just leave it on water. So wouldn't waste any time on that. Accessories, component family. This is where you can select what you want to use. It'll default to our U series. Just know that if somebody is stuck on DL series, they don't want to get off of it, you can select DL series. And that'll give you your RTPCs, your RTSs, things like that, and not part of the U series. The ULL series, I'm not even sure that's available on all programs. But if you're ever using a long line cable, I'll just bring it up. There are different boxes for series long line cable. They look identical, but they are different. So keep that in mind. Power kit option, you can do a lighted power kit. Keep in mind, we do not have a power lighted kit for class 1 div 2. This would be for an ordinary area only. So I'm not a big fan of doing one at the beginning. If you're going to do one, do a lighted end seal at the end, and you can put that option in here. You can also do a above the insulation end seal, which would be our UES. You can force that to give it the right information in the bill of materials. Control method, ambient sensing, line sensing. It's that simple. With caustic, we're going to line sense it. So I'm gonna change that back to none for now and show you something else. If you look at it down at the bottom, we've got a kind of a warning message here. It says our max control temp exceeds our heater max maintain. Suggest using line sensing control. That's where you would come up here, force that you are using a line sensing control, and it takes away your error message. The type, you can use local mechanical, whether that's a simple thermostat, or if it's a local electronic, that could be a DTS, that could be an ITC, or a panel. We did used to have this used to work where you could select the actual panel model, but that's being reworked, so that's not available. So we'll just say we're going to use a local electronic for now. If you use a local mechanical, like a thermostat, you'll force a separate power box. And what that means is a DTS will provide a power connection kit and your control. So it's all in one. If you're using a TXL or THR thermostat or B100, E121, just a regular thermostat, you do have to force a separate box. So that's what that is in there for. So with that, only other option you have are your project settings, which are up here at the top. I always like to fill these in. It's really nice to fill this in with the information you got from your pipe design worksheet, with the project name, the facility, the project number, who the customer is. You can put your name in there that you designed it. And this will show up on the header of your reports. So it's a real nice touch to add in there. And if y'all are imperial and metric impaired like I am, somebody only gives you metric information, metric lengths, Celsius temperatures. I use this, I'll set it to metric and I'll input what they gave me and then come back and change it to imperial to see, well, you know, what I'm more comfortable dealing with. So that is available. You can change your units back and forth. So with that, reports. You should all be familiar with all the reports we have. We can go to a standard bill of materials. And it gives us everything. You'll notice it gave us that TXR thermostat, but we had to force a separate box, a UPC. So there's your bill of materials. And just like all of our reports, you can export these to PDF, to Word, to Excel, however you want to. On your summary design sheet, this is where I use my area. Say we had different panels. So I want to group it up here in the upper right-hand corner. You can group it. I say by area name. And you'll notice in the actual printout it says area name panel 1. If I had area name panel 2, it would split them and put them, you know, it would designate it into the different panels. So that's why I use that. But there's the reports. One report that I don't see a lot of people use, and I would encourage you to, is the detail report. Send this if a customer hasn't given you a lot of information. Send this to them. This is just like it says. It's a detailed report that's going to show every piece of information, every piece of design criteria that you used to come up with the bill of materials that you gave them. I can't stress enough, excuse me, how important that detail is. So keep that in mind that is there. So with that, I'm going to get out of here and we're going to go real quick. I'm going to show you how to import a line list. So we're going to remove this line. And if your customer can give you a line list in Excel, I mean, encourage, I can't encourage you enough to do it. It simplifies everything, all your inputs. You don't have to do them one at a time. Find this. So I've got one here just called sample line list. So you pick the Excel file and it's going to open up and look like this. At the top, you're going to see what you can assign every row as. So we obviously know this is line name. So we're going to come in here and put, where to go? Line name. The revision, we'll leave it not assigned for now in the sake of time. This is your P&ID. It's the only drawing number we have. So we're going to list that as the drawing number. We're not going to assign this, our maintain temp. Well, this is actually pipe diameter. So we're going to change this to pipe diameter, pipe length. All you do is come through here and select what you want to assign them to. Number of valves, we don't always have this, but it's really nice, even if you want to make your own spreadsheet to do this. It'll save you a lot of time in the long run. Flange, and then number of supports, additional cable, additional length, our installation type, our installation thickness, our maintain temperature. Y'all don't fall asleep on me now while I'm doing this. Minimum ambient. Max exposure. And voltage is what it was. Voltage and safety factor, we can put that in there as well. And then we'll leave the rest of these all unassigned. So whenever we do that, we will hit the import button. And it just imported every one of those into your program without having to go in there individually and do them. So if you have, I would say more than 10 to 15 lines, so maybe 20 lines. I mean, it's actually, I find it more beneficial to put the information into a spreadsheet and upload it into ChromaTrace rather than clicking through all the input information. Whenever you do this, we can, if you have something wrong, it'll give you a warning. It'll give you a little caution symbol here. So you just select on that line and going to figure out what's wrong with it. So with that, that leaves about 15 minutes. If anybody has any questions, and Dee, I know you got a couple of things. And one thing I will add on import, if you do a design yourself and you want myself or you want Chad or you want somebody to double check it, you can email us the ChromaTrace file and we can go to import and we can import the whole project, or we can just import the file itself. And we can look at it, we can share a screen, we can go back and forth, and we can look at it. If you get a bad error message, you don't know why you're getting it, send us the file. We'll open it up, we can share it, we can look at it. So keep that in mind, please. And with that, that's about all I had. Just kind of quick, basic, down and dirty
Charlie,
run through.
don't come off the screen yet. Now, so you just imported that cleanly. You could generate a bill of material report just from that, right?
It's right here. You go to report, hit bill of material, and there it is.
I mean, think of that for just estimating project size and stuff. That's fantastic.
Yep, and you're not always going to have all the information like I have in that sample. You know, I may have cheated a little bit when I built that sample list and included a lot of information we normally don't get. I just wanted to give you an idea of all the options that can be imported and how simple it is. It's a lot easier to input information into Excel than it is clicking, clicking a window on ChromaTrace.
No, it's a great example. Well, Charlie, that was a lot. That was really well done. A lot of folks out there. Any questions for Charlie?
I have a question. Charlie, what's that min controlled temperature, uncontrolled temperature at the bottom? What does that mean?
Okay, no, that's a great question, Ami. I should have covered that. So whenever we get a design on any line that we do, your minimum controlled temperature. So that one specifically is your maintained temperature, which we're maintaining 40 degrees. That line could possibly get as high as 76 degrees by the time it shuts off. That's a minimal controlled temp. A max controlled temp, and Cassie, if you're on, correct me if I'm wrong here, your max controlled temp could get to 164. Your uncontrolled temperature, that is if your controls failed on a 110 degree day, that is the maximum that pipe could get to. And I don't think that max control temp number, Ami, now that you bring it up, I don't think that's correct. It should not be, with it being controlled, that number should not be that high. But that's what your minimal control temp, max control temp. Your uncontrolled temp is in a runaway condition. Everything's failed. Only thing that hadn't failed is the full voltage going to the heating cable. And that's the maximum temperature that pipe could see. Your maximum sheath temperature, that is exactly what it is. It's like if you were dealing with a heater on a circuit heater or anything else. That is the max sheath temperature that you can get on the outside of a heating cable. But that's a great point. And if anybody has anything to add on this minimum and max control temperature, because it is very confusing, please speak up, because I would love to know why these two numbers match.
Hey, Charlie, this is Chad. Hey, they match because if you were to wanted to raise the set point on a controller, think about it. The highest you could go would be whatever the uncontrolled temperature would be. That's what I think. That's why they're the same, right? If I said I want my maintain to be 164, that would be the most I could get out of that.
That's very possible, Chad.
Yeah, that's how I read that.
Yeah, that's very possible, and I'll try and get some clarification on that.
Thank you.
You're welcome, Mommy. Great question. Thanks for bringing that up. And I would like to do one, later on down the road a little bit where we get a little more into it. This was very basic, but where we really look at optimizing the design. ChromaTrace is a great tool for doing that. If we want to play with the voltage a little bit, play with the insulation thickness, where we're forcing number of passes on a large pipe. A lot of times you can have a 20-inch pipe and it's going to give you a single pass of cable. Well, we know that, in the real world, that's just not always going to happen. We know we need to cover more surface area. So down the road, we'll get into a little bit more advanced optimization of the program.